In this video, we'll look at how to install and run the Alethiea app on a Mac OS. So the first thing to do is to go on the GitHub page and scroll further down to have the instruction. So the first thing to do is to make a copy of this repository on your computer. So I created a test folder in which I will clone the app. Takes a couple of seconds. And then cd into the app. And then you will also need to install these if you don't have them. So these are the four main technologies which are used by Alethiea: Ethereum, IPFS, Node, and Electron. Don't really need to know exactly what they do to be able to install the application. And then to run the project, you have to cd into the application folder, which we have done, and run npm install. So this is going to download and compile the dependencies which are needed, and it takes about 1 minute on my computer. So in the meantime, we can have a look at the structure of the application folder. And an important file is this package.json, which will contain here the main commands that we can use. So start the main application, start an Ethereum local node, and start an IPFS local node. So those two will be needed to have a simulation of the Ethereum and IPFS networks. And in the scripts here, you have more details about what is done by these installation scripts. You can look at the IPFS local, for example. This starts the IPFS node. So of course, go to the IPFS website to have more information about the documentation. But basically, what this will do is create a local IPFS develop folder to store the document that we want to share with others. And once we have created our node, we can start the daemon. Another thing is the app folder, where here we're going just to modify a couple of lines in this file, just to make sure that in this demo everything runs fine. All right. So now it's compiled, and we can start an Ethereum local node. So that's just a simulation of Ethereum, and we have now a set of fake accounts that we can use to use the app. Now in a second tab, we'll have to start the IPFS server. So let's go to the Aletheia app, and then here we can check that the IPFS develop folder is not there yet. If I start IPFS local, that will create this IPFS develop folder where all the files that I upload on the network will be stored. Checking again, so now it's there. You can check the size. It's almost empty now, and it will be filled with documents which are uploaded with Aletheia. So now the IPFS server is running. It's telling me that the UI is here on port 5001. So I can go there and the browser and go to this web UI path to see information about what's there. So sorry, it's in French, but basically it's telling me here for the files what are the local files. In IPFS, files or folders are addressed by hash. So this is the hash of a folder. I can look at what's inside, clicking on the link, looking at this other one here. So I have a set of folders, and then I have documents, and all of this indexed by hash. So if I go back to starting Aletheia, so now the last step is to start the application. So here from the Aletheia app folder, I can start the Electron application for Aletheia. It's compiling the contract, pushing them on the local blockchain, and starting the app. And here is the app for the moment. So it's not really friendly, but it's telling me that here is the address Ethereum account, so which is the first one that was created on the fake Ethereum blockchain. They have some balance, and so now I can submit some paper. So for the moment, there isn't any submitted paper, but let's submit one, clicking on permanently share a file. And let's take, for example, this article, which is from Tim Berners-Lee about the World Wide Web from '94. And okay, so now it's been pushed onto IPFS. And I can see that if I go to submitted papers, here is a hash of that document that I pushed on the blockchain. So if I go back to the web UI and if I refresh, then I see that one hash has been added. So the hash for the document is this QMBXY, which is this one. So if I look at row, well, document is here. So this is all served locally. So if I go back here, third tab, and looking again at this IPFS develop folder, now I see that it's much bigger, so there is this PDF which is now inside. So the nice thing is that anyone who is connected to IPFS with this hash, even if it's only for the moment stored on my computer, would be able to retrieve it and make a copy on its own computer. So to check that, we can use this gateway node from IPFS. And if I provide the same hash, then what this is doing is that it's going to look for this hash, finds out that it's on my computer, retrieve it from my computer, and then serve it to me. And so if you did the same on your computer, you'd be able to have access to the file. And the great thing is that if I now disconnect, so now my IPFS node is not running anymore. If I reload from the gateway, then I still have it because now there is a copy on another computer because someone else has loaded it. So we can do it again with another paper. Let's take the manifesto from Aaron Swartz. And of course I need to restart the IPFS node. Okay, so now it's uploaded. If I check locally, I can see it's there. So now if I go out of IPFS, and if I tried to get the hash of the paper, so here, this is the hash for the manifesto, then I would not be able to download it because the only copy is on my computer and I disconnected from the network. But if I go back and start my node again, and try to reload this, now IPFS is trying to find who has this hash. I have it, so it can take a few seconds for it to find that out. I can check that locally. Now it's there. So that's this QMSP right there. And here should be faster. All right, so now it's there. And so again, if I disconnect, now it's still available, and there is a copy somewhere on the web.